Okay, it's time to have a look at this little radio. A few of you have confirmed that it's actually an international radio made in Japan. I'm just going to give it a quick degunge in a minute with the wet wipes before I handle it. It's pretty mucky. I think these have been just stuck in a box in a garage for a while, so yeah, I'm pretty sure I can do something about the brass inserts in the middle, but I do need this label really. I need a good photo of one so as I can try and make something up. Spiders and all sorts in this one. Right, I think that's a little bit healthier. Ooh, it's actually very manky. It was. So let's have a little look what we've got then. It's a 9-volt battery, which we know, but I'm not very confident about this. I don't know what's gone on there, so I think before I try and power it up I'm going to have to try somehow to get the chassis out. And that does look straightforward. So it's a GP 9-volt battery then. Let's have a quick look to see if that's got any actual power left in it. Never throw batteries away unnecessarily. So let's go across the positive and negative. 2.6 volts. I think that one's a scrapper. In the bin. Okay, there is absolutely no service information about from this this model, so it's really a case of trial and error. There is a grub screw in there in the spindle, which I'm just loosen off there, hopefully. That will come off. Oh, there's even a little felt washer in there. You normally get that on the better quality sets. That's a good sign then. It's got a sort of certain quality feel about it, to be honest. Oh, looks like we've got a... yeah, they have come unstuck, which is a pain because I'm going to have to realign those. Not sure if there's any alignment marks on them. Nope. Oh well. So that's that. Let's have a look at the back now. To get a little tub going for this one. Just keep the bits from scratching. Let's have a look in the back. I would normally try and power it up, but because someone's had a mess with the battery terminals, I'm not going to do that. I'm going to take it out of the chassis first, just so I can see what on earth has gone on. So it looks like a smaller screwdriver. It looks like just 4 wood screws hold it in. They're not wood screws, they're actually machine screws. There we go. 3. One came out whole. And the 4th one. I'm hoping this will now come out of the chassis, and it will, give or take. There's a connection on the side, see if I can get that out. There we are. Should pop out. There we have it. Let's get all the screws and bits in and out of the way. So we have an intact speaker. Airspace tuning cap. Good stuff. I think people that have been posting on my page have said this is around about 1960s. So there's some strange, very strange wiring going on, which does concern me a little bit. And there is some pieces adrift by the looks of it as well. And they've unfortunately hobbled in a power supply. Now I really haven't got, I mean, what is that? What is that? It's a 9-volt supply. Oh my god. I don't know if you can see this, but let's zoom in for a look. Well, this ain't good. So I don't know if you can see that connection there. Oh, it's come off. That's because it was never soldered, just wrapped around. And also we've got a bit of a bizarre connection down here as well. I don't know what's gone on with that, but I would assume that's the original negative connection. Somebody's done something horrible to it there. So, oh my god, what has gone on there? Well, I'm just going to cut that off because that's horrible. So let's assume for now that's our positive on the volume tuning control here. I'm going with this as a positive, and this wire that's sticking up from the board is the old negative, but then the capacitor looks like it's been messed with as well. Let's just bear up a little bit of wire there for the time being. So, power supply set at 9 volts. Let's get those terminals out, pop these in. Positive, negative, Possibly. Oh, we have noise. Get rid of those. Very little tuning on this. Just like a single band this is. I mean, the dial is reading, let's say 5.4 to 16. I don't know what that means. It certainly isn't 5.4 to 16 megahertz. There is some turn the, yeah, that's full volume, so there is it might be medium wave. That's maximum volume, so definitely summing up with this. It's either transistor in the output stage or my power lead. Right. I've sorted my power lead to resolder that, but I need to sort this. Sort this volume out. Need to find a talking station really, because I'll get done for copyright again. There's a very quiet station there. Cool. This set has been messed about with. Right, well here I'm just jumping a low value capacitor electrolytic across some of the capacitors in this one, some of the electrolytics, just to see if I can improve the volume. So certainly there's a few that are a little bit untoward. There's a couple there to try. Capacitors. That's one. And that's the other one. So both 30 microfarad radials, well axials actually, but not getting axials back in it, it's having radials. Let's go see if these 47s are, yeah, they'll reach, yes. I'm going to chuck a couple 47s in there, I'm going to waste my radials on it, my axials, I keep getting axials and radials mixed up. So I'm going to pop these two out and try again. Okay, I'm just messing with the battery connections at the moment. See if I can get that back as it should be. So I've connected these two PP9s in parallel. As in series it will be 18 volts, parallel it's 9 but with a bit higher ampage. So that's all connected up. As you can hear, working fine. So I've just got to somehow work out how to wire that up now. Well, they're not matching, but you get the gist. And I've just got two fly leads going off the junctions of the two batteries. So I basically need to connect the positives together, the negatives together, and then connect them to the terminals. So what I think I'm going to have to do is solder that one to there, extend this one to there, and somehow extend these over to here. So it's cable time. Let's have a look what we got. So in a bit of shrink sleeve. Piece of red and a piece of black. I decided to speed this bit up, not particularly interesting, but gives you an idea of what I'm up to. Basically just added in some extra cable in there. It's slightly thicker than the original wire, it's a stranded wire. I think the original may have been solid, but it gives it a bit more flexibility. Just putting some shrink sleeving on there, using my heat gun, just to hot air gun, just to shrink it back in. That's 3-to-1 shrink sleeving. I think I got a kit of that from one of the electrical suppliers. As I say, it's just a case of redoing what was there originally. There is a circuit diagram of this radio so I can see what's happening with it, but really it's making a nicer job out of it. Whether I keep this radio or not is another thing, but you know, I think it's worth saving. And certainly doing it this way will mean it's good for many years to come. So just going to finish this little bit off and then get stuck into those capacitors, and that throws up a few surprises as well. So carry on watching. There we are. So that should be batteries done. Let's have a look. Was a little bit astray on this one. So an old rough old battery. Right.
Subject to availability, offering 20th of June. Protein contributes to a growth in and maintenance of muscle mass. Emailing staff, emailing customers.
Still at maximum volume. So, let's get those batteries out of the way now. We know that works. Capacitor time then. That's basically that's all my new caps there. I'm going to get those in, and then we're going to fire it up again. hopefully there will be life. Let's get all this blooming tape off of them. What's that one there? 2.2 microfarads. Look at that one. Okay, so bear with me, I'm going to get these capacitors out, put new ones in and see how we get on. Okay, well that's the recap done, and some very eye-opening results as well. So this radio was pretty deaf before and very quiet. This is all 7, actually 3, 6, 3, 6, all 8 capacitors I've taken out. I put 8 back in on my 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. What's the 8th one? You haven't left one out, Graham, have you? 1, 2, 3, 4, 5, 6. Ah, that's it. No, there is 8 there. One in underneath there, look. So they're all done. As I say, I've replaced axials with radials, but as I say, they are quite small, these new ones, so there shouldn't be any problems. But before I turn it on and show you what's going on, I thought I'd let you have a look to see what sort of readings I got off of these. What I did these one by one. Always good practice whenever you're changing components, do one at a time. Make sure you can see that. Yeah, you should be able to see. So my peak ESR meter and my 8 capacitors. Let's do them in order. We've got a couple hundred microfarads there. We've got 300 microfarads, 30, 30, 10, and 2 5s. So let's try the hundreds first. Let's see what we got. So again, I'm using my peak Atlas ESR meter. First one. Okay, 159.6 microfarads. ESR is okay. 0.89. But really, 100 microfarads, that shouldn't really be over 120. So that one is high, but not a circuit killing component. Let's try the next one. Again, another 100 microfarads at 10 volts. 135.7 ohms. Again, high, out of tolerance, but not a circuit killer. Now I've got an axial now. Again, 10 volt, 100 microfarads. Oh dear. Right. Well, that's showing more than 40 ohms ESR. That would almost certainly have desensitized the circuit anyway, definitely. So that one's had it. Right, let's move up to the 30 microfarads. See how we're doing on these. Again, had it. Very high ESR, over 40 ohms. The little beep you heard. Try another 30. Okay, well that's actually got some capacitance left in it. It's measuring 8 microfarads, but again over 40 ohms resistance, so shot. So it's 3 out of 8 so far gone. Now what have we got here? 10 microfarads. Let's try this one. This is at 3 volts. Ooh, okay. It's 11 microfarads. It's of a low voltage, a low capacitance one, so definitely not good, but not a killer. Let's just try a modern 10 microfarad to compare it. This is a little Philips one that I just got knocking about here. Bear in mind that's 11.2 ESR. 2.3, so you know 11 is pretty high. So that one is shot. Now our little baby ones. These are 5 microfarads at 6 volts. Oh, open circuit or low capacitance. Right, it might be that this won't read down that low, but should do. And that one's reading, that's another 5 microfarads, reading 40 ohms. Let's just try those on the LCR meter. These, this one goes down a bit further on capacitance. See if they're reading anything. Well, that is 5 microfarad, it's reading at 25 nanofarads. Shot on that one. $625 nanofarads. So, as you can see from my piles there, they were just about usable. Those are all absolutely shot. So out of 8, there was only 2 that were any good, and they're out of tolerance really, but they wouldn't have stopped the circuit working. So